Hello everyone, welcome to mathematics class standard 6 chapter 14 fundamental geometrical concepts. So the word geometry has been derived from two Greek words. One is geo and another one is metron. Here geo means earth and metron means measurement. Thus the word geometry means measurement of earth. What do you mean by geometry? Geometry means measurement of earth. So the first, in this chapter we learn about fundamental concept of geometry such as point, line segment, line, ray, angles, curves, triangles, quadrilaterals, circles, etc. First of all, we discuss about a point. So what is a point? A point is a mark of position, usually a fine dot mark with sharp-edged pencil on a plain paper represent a dot. So here in this paper, this is a point which is represented by capital letter A. So it is point A. We denote a point by capital letters either A, B, C, P, any. Here it is A is the point. So a point has neither length nor breadth nor depth. A point is a dimensionless. The point is dimensionless. It has no breadth, no length, no breadth, no depth or thickness. And it is point is represented by capital letters of English alphabet. So here in this picture it is point A. Now second one is line segment. Let us draw 2 points on a paper. One is point A, another one is point B. Now draw a straight path from A to B, and this AB is called the line segment. AB is called this is line segment AB, and it is denoted by bar over AB. We may call it line segment AB BA. We may also call it line segment BA, and denoted by bar over BA. So the line segment AB has the same length as that of BA. So a line segment has two endpoints. The line segment AB has two endpoints. One is point A and another one is point B. Distance between the points A and B is called the length of line segment AB. Thus a line segment has a definite length which can be measured. A line segment has a definite length which can be measured. It can be represented by line segment AB can be denoted by bar over AB. Line segment BA can be denoted by bar over BA. Now measurement of line segment. To measure the length of line segment, we need a ruler, or we use a ruler. A ruler is marked in graduated in two scales. One is centimeter scale and another one is millimeter scale. Now measure the length of the line segment PQ given below. First method, place the edge of the ruler along the given line segment PQ, keeping 0 centimeter mark of the ruler at point P as shown in the figure at point P. Now read the mark on the ruler against the point Q. This is the point Q. So we find that the point Q is small division ahead 5 centimeter. That is, this is 5 centimeter and two small division ahead of 5. So the length of PQ is length of line segment PQ is equal to 5.2 centimeter. This is method 1. Another method, by this method we can measure the length of the line segment. Now line. A line segment extended endlessly on both sides A line segment extend endlessly on both sides is called a line. A line segment AB, this is the line segment AB, which extend on both sides and marked by arrow mark on side A and another side on the side. On the first one arrow mark is on ends A and another arrow mark is on end B. So since it extends endlessly, a line has no endpoints. A line has no endpoints. Two arrows in opposite direction of a line indicate that it extends indefinitely in both directions. So a line does not have definite length. Since the line is endless, it cannot be drawn on a paper. We can simply represent a line also as shown above. So by drawing a line AB would mean to draw a part of it, mark 2 points A and B on a paper and put arrow mark at the two ends in opposite direction. Sometimes we denote the line by small letters such as small l, small m, small a, and etc. Symbol it can be denoted by this line AB can be denoted by AB by putting a bar over AB by putting two arrows on the two ends of the bar. Now ray. A line segment extended endlessly is called a ray. A line segment AB extended in the direction from A to B and marked by an arrow mark at B. So it represents a ray AB and denoted by AB, ray AB. A ray has only one endpoint. This endpoint is A. Since a ray is endless in one direction, it cannot be drawn on a paper. We can simply represent a ray as shown above. A ray has no definite length. Ray AB is a ray with initial point A extending endlessly in the direction from A to B. It is represented by the adjoining figure. This is the ray AB. And another ray is BA. It starts from point B and extended endlessly along the direction of B to A. Now opposite ray, two rays with the same initial point and extending indefinitely in opposite direction along the same line are called opposite ray. You see in this figure, OA and OB are two rays with same initial point O and extending infinitely in opposite directions along the line L. So OA and OB are opposite rays. Now surface. A solid has a surface which may be curved or flat. It is a surface, it is a flat surface, and it is a curved surface. For example, surface of the ball is curved, surface of the wall is flat. Now plane. A plane is flat surface which extends indefinitely in all directions. The surface of smooth wall, surface of the top of a table, surface of a smooth blackboard, surface of the sheet of paper, surface of the calm water in pond. These all are the examples of the portion of a plane. Part of a plane. Portion of a plane means part of a plane. Since the plane is endless in all directions, it cannot be drawn on a paper. In practice, only a portion of plane is drawn and is represented by a rectangle or parallelogram. Remember, it is very important, since a plane is extended indefinitely in all directions and less, so it cannot be drawn on the paper. Only part of the plane is represented by a rectangle or a parallelogram. A line named by taking different points on it which are not on the same line. In this given figure, there is point A, B, and C. These 3 points are not on the same line. Now intersecting lines. If there is a point P common to lines L and M, this is line L and this is line M. These two lines L and M intersect or meet at a common point P. We say now, so we can say that two lines intersect at the point P, and this point P is called the point of intersection of the lines. Here the two lines L and M are meeting actually at point P, but in this figure these two lines L and M are not actually meeting at the point. When we extend their other ends, they appear to meet at point P. Now parallel lines. Two lines L and M in a plane are called parallel if they do not intersect even when produced, and we write them as L parallel to M. This is the symbolical representation, L parallel to M. The distance between two parallel lines always remains the constant. The distance between two parallel lines at any point on these two lines, at any points on these two lines remains constant. Opposite edges of ruler, opposite edges of the top of the table, railway tracks are example of parallel lines. Now concurrent lines. The three or more lines in a plane are said to be concurrent if all of them pass through the same point. Here you see four lines, namely line M, line M, line N and line P intersect at point P. So these four lines, lines L, M, N and P are concurrent lines. And point P is the point of concurrence. Here point P is the point of concurrence. Now collinear points. Three or more points in a plane are said to be collinear if all of them lie on the same straight line. You see here 4 points A, B, C and D lie on the same straight line. So these 4 points A, B, C and D are collinear points. Here point P, Q, R and S, these 4 points do not lie on the same straight line, so the points P, Q, R and S are non-collinear points. The figures traced out with the help of sharp edge of a pencil without lifting the pencil are called curves. Each of the figure given below are curve. This is a curve. This is also 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 curve. These all figures given below. Each of the figure is curve. There are two types of closed figures. One is closed and open figures. A figure which begins and ends at the same point is called the closed figure. In the figure, this is a closed figure. This is also a closed figure, and this figure is also a closed figure. A figure which do not end at the same straight point is called an open figure. Here, this is an open figure, and this is also an open figure. Now polygon. A simple closed curve figure form of three or more line segment is called a polygon. The line segment which form a polygon are called sides. The point at which two adjacent sides of a polygon meet is called vertex of the polygon. So a polygon with three sides are called triangle. Polygon with four sides are called quadrilateral. Polygons with five sides are called pentagon. Polygons with six sides are called hexagon. You see Let us, this is point A, point B, and point C. So the triangle has three line segment. One is line segment. There are three sides AB, BC, and AC. Two adjacent sides AB and AC meet at point A, so A is a vertex. Similarly, sides AB and BC meet at point B, so point B is a vertex. Two adjacent sides BC and AC meet at point C, so point C is also a vertex. Now, plane figures. We draw figures such as triangle, rectangle, square, circle. These all are plane figures. A figure triangle. You see here, a figure bounded by three line segment is called a triangle. What is a triangle? A plane figure bounded by three line segment is called a triangle. A triangle. Here, triangle ABC is a triangle. Symbolically, it is written as triangle ABC. So a triangle has three vertices, namely A, B, and C. A triangle has three sides A, B, C, and AC. Now, quadrilateral, a plane figure formed by four line segment is called a quadrilateral. Here, this ABCD is a quadrilateral. It has four sides AB, BC, CD, and DA. It has four vertices, namely A, B, C, and D. Various types of quadrilaterals are. First one is a rectangle. A quadrilateral bounded by two horizontal line segments AB and CD and two vertical line segments BC and AD is called rectangle ABCD. A rectangle ABCD has two opposite sides are equal in length. So AB is equal to CD and BC is equal to AD. Each angle is 90 degree. Angle A is equal to angle B is equal to angle C is equal to angle D. Each angle is 90 degree. The opposite sides of a rectangle are equal. Each angle of rectangle is 90 degree. Square. A quadrilateral having all sides equal and all angles equal is called a square. In square, here PQRS is a square. Here length of PQ is equal to length of QR, length of RS is equal to length of SP. And each angle is 90 degree. Angle P, angle Q, angle R, and angle S. Each angle is 90 degree. So it is a square. So PQRS is a square. Now another type of quadrilaterals, parallelogram. A quadrilateral in which opposite sides are parallel is called a parallelogram. In this figure ABCD, this quadrilateral ABCD, opposite sides are parallel. CD parallel AB, AD parallel BC. You see here AB parallel CD and AD parallel BC. Hence ABCD is a parallelogram. The opposite sides of the parallelograms are equal. It means that AB is equal to CD and AD is equal to BC. Opposite angles are equal. Angle A is equal to angle C. Angle V is equal to angle T. Rhombus. Parallelogram having all sides are equal is called a rhombus. So SR is equal to RQ is equal to PQ is equal to SP. And opposite sides are parallel. SR parallel PQ, PS parallel RQ. Hence PQRS is a rhombus. Now circle. You see, if you take a coin, place a coin on a piece of paper and draw its outline with the help of pencil. Now you will get a figure, and that figure is a circle. So a bangle, a wheel, a coin, etc. are circular objects. Interior of a closed figure. The part of the plane enclosed by boundary of a closed figure is called its interior. The part of the plane lying outside the boundary of a closed figure is called its exterior. For example, in interior, you see point A, B and C in the interior of the figure, in the interior of the circle, lying where F, G are the points lying in the exterior of the circle. So point A, B, C are called the interior points and F and G are called the exterior points. In figure 2, P and Q are in the interior of the figure, R lie on the figure. This you see this point, R lie on the figure, S lies in the exterior of the figure. Linear boundaries of a figure. If the boundary of a figure are straight line only, these are known as the linear boundary of the figure. For example, sides of the rectangle, square, parallelogram, these are consist of linear boundaries because their sides are, each side of the rectangle, square, parallelogram are straight line. Now curvilinear boundaries of a figure. If the boundaries of a figure are not straight line, then these are known as curvilinear boundaries. For example, boundary of a circle, boundary of an oval. So this is all about the basic concepts of geometry. So exercise 14a based upon these concepts. So try to solve these problems, and if you have any problem, you post your queries on the group. I will help you in solving the problems. And with this, the chapter 14 is over. So thank you.